A statement from Thomas Ken, previous NASA science chief, on the send-off of JWST. James Webb denotes the start of a new period in stargazing. Webb will extend and test our cosmology and our comprehension of planets and the beginning of life. What started ideally transformed into a calamity. James Webb stunned researchers with the emergency. Will it deteriorate, or will a new disclosure of the James Webb Telescope further the discussion in physics? The conversations about old hypotheses and who is correct or wrong to be sure come to a brief end. However, what precisely does this mean? Have researchers truly unwound the secrets surrounding James Webb's incomprehensible disclosures? Or are we just being slowed down with shaky clarifications? James Webb should bring arrangements. However, the 11 billion project dove cosmology into a significant emergency. All pieces of inherent science related to space are now experiencing a purge of the sort we last saw in the medieval times with the shift to the heliocentric perspective on the world. Now, we might need to recognize that the underpinnings of our cutting-edge physics are also imperfect and that we have not come close to understanding what our universe truly is. But how is this possible? The present astronomy, or in other words, the study of the physical quantities and relationships in the universe, depends on the fundamental principles of physics which essentially return to analysts of classical times, the medieval times, and particularly to Sir Isaac Newton. The primary observations of mechanics and elements were made in antiquity. Quantities and forces were described for the initial time, and later Newton discovered gravity, which is so significant for astronomy. We built our scientific perception of the universe on these foundations. We extrapolated quantities and forces that were substantial and visible on Earth to the universe, and this produced some consistent results. However, then the space we can see got increasingly big, and at a certain point our known quantities no longer fit to describe what we see. This emergency began with the issue that unique methods for measuring the age and expansion pace of the universe led to incongruous results. Local measurements based on galactic objects within the universe gave different values than measurements of the early universe based on the cosmic microwave background radiation. We know this discord as the Hubble tension. While the Hubble constant indicates the expansion pace of the universe, in the summer of 2022, Webb found so many old and deeply created systems in space that questions arose regarding how the age of the universe was determined. Our universe can hardly be 138 billion years of age if, thanks to Webb, we see galaxies that were already developed 200 to 100 million years after the Big Bang. According to the estimations of our physics, universes need billions of years to form. In the case of the systems found by Webb, this would try and imply that the time of their arrangement was before the Big Bang. Our old cosmology, according to which the universe began with a Big Bang 138 quite a while back, has been expanding from that point onward and has gone through a sluggish interaction of development of matter, can't be right. We are at a junction. It is possible that we are committing an error assuming that we believe that our natural physics can be applied to the entire universe, or we have up until this point only unraveled a little piece of the physics that really exists. The ancient scientist Hermes Trismegistus once said, "As in little things, so in great things." According to this adage, every one of the physics that exists in the universe ought to also be found on the planet. However, perhaps we have disregarded forces and aspects on our planet that we are now seeing in the cosmos. Webb breaks all records. It's awesome. This telescope can get incredibly weak light signals. Webb's 18 honeycomb-shaped mirrors detect light that has crossed existence for more than 13 billion years. An exceptional exposure technique makes these weak traces visible for the initial time. Thanks to this new revolutionary technology, we saw the light from the most distant galaxies that formed soon after the Big Bang. In the summer of 2022, these G galaxies were a sensation and at the same time a touch of disappointment. Instead of baby galaxies, Webb shows impeccably created galaxies that appear to be several billion years of age. But with an age of 135 or 136 billion years, this can never be the case. Nowadays, scientists sometimes say that the objects and the pictures are inconceivable or not genuine. But Webb can show us the truth. Science should now admit that it has probably been incorrect for over a century. That is generally how old our standard cosmological model is. What we see here is real. Webb works impeccably. It's just that large parts of our science are still unable to come to terms with the new pieces of insight. Some of the old conservatives, who would rather not address the new insights directly, energetically go against the conclusion of the Big Bang or the possibility of evolution. In the medieval times, it also took many years before the Church was balanced and ready to concede that the Earth was not the middle of the universe, despite overwhelming evidence. Today, we have a similar situation. Although we see ourselves as much more modern, today we have a similar situation. Scientists who broadcast a new thing may no longer wind up in jail like Galileo Galilei, but the battles between scientists and the antagonism toward new things are still there. Imagine you have spent a lifetime researching and firmly believing in something, and then suddenly you see images or another side of reality that tells a different story. Perhaps your mind would also rebel against this right away, and it would take some time before you could accept the new truth. As everywhere, there are some who are quicker to adapt and others who take longer. Many liberal and young scientists are enthusiastic about Webb's discoveries. Rohan Natu, the leader of the Glass Z11 system, and Steffi Lin, who discovered Macy's universe, belong to this receptive age of researchers. They see Webb's images with an open mind and have been studying them since the first moment of publication. Both astronomers emphasize several times in interviews that we simply cannot yet understand what will happen in astronomy at this moment. We need to wait for more measurement results, studies, and, of course, Webb's latest pictures. Was it Hubble's weakness? We must investigate the catastrophe. One of the great controversies in modern cosmology concerns the Hubble constant. This is the rate at which the universe is evidently expanding. In the 1920s, cosmologist Edwin Hubble found that distant galaxies were moving away from us. From this, he concluded that the universe is expanding. The idea was later expanded, and the Belgian astronomer Georges Lemaitre proposed that this expansion started from a single point, the Big Bang. Today, we definitely know from alternative methods that the expansion of galaxies can also be figured out differently. These approaches too give an ENT image fully. However, they were ignored for a long time because the old theories were considered additional likely. But the more we see of the universe, the more discrepancies arise. This didn't just start with Webb. Even years ago, there were regions in space where the expansion was acting differently. It was as if these regions were sometimes quicker and sometimes slower, or perhaps denser or emptier. This led to speculation that there might have been some starting points or that our universe is even permanently handled by some sources which don't necessarily all have had a beginning at the same time. Or at every single alternative thought about the shape, nature, and age of the universe arose again. But researchers continued to adhere to the old theories of the Big Bang and an expansion. This was possibly a mistake. We have currently briefly learned about the Hubble pressure. In short, it indicates clear differences in distance estimates in the universe depending on which fixed points we use as measurement constants. Now, scientists believe that the Webb telescope, as its mission progresses, will be able to resolve this tension by making accurate measurements of the distances and red shifts of galaxies. This could correct errors in previous measurement methods and pave the way to new advanced physics. In the end, all researchers have given their all in tracking down explanations and theories, and they have advanced mankind's knowledge of the universe. We should therefore not discuss guilt but rather look forward and celebrate in every new examine why. Regardless of whether it seems new or even shocking at first, new theories and alternative explanations are on the rise. We are likely at the interesting start of a new science. New examination of these oldest places of light could show us whether they are an N-circle or planes of very massive dark holes. And as in their area, we would then need to return to our cosmology and discover whether dark holes played a substantially more significant role in the discovery of the universe than previously thought. One theory that points to this comes from the English scientist Roger Penrose, who believes that the universe is constantly recreating itself in cycles and that dark holes could somehow endure such advances as tremendous stores of information. Penrose published this theory sometime before Webb was sent off. Although England is a renowned researcher, his work was not acknowledged. That is now changing. Webb's mission has already barely started. We already have a second profound picture, and we have the discovery of a very old design that is so big that yet it also doesn't pinch into the young universe. This evidence is growing. We still need to sit back and watch what new pictures from Webb will reveal. The telescope isn't only exploring the young universe but also is working close to the clock to complete our knowledge of exoplanets, find new worlds, shine new light on our own planetary system, and picture the most massive and beautiful structures in the universe in exceptional detail. Each of these observations in the universe is ultimately a piece of the puzzle that completes the general picture. Even measurement data on exoplanets can expand our focus on the general picture and give us important clues about unknown forces, anomalies, or previously unknown peculiarities. There must be something like a fundamental framework, and our researchers are searching for its sizes, numbers, and designs. A statement from Adams, the former NASA lead researcher, on the send-off of JWST, the James Webb Space Telescope, envoys a groundbreaking epic in our understanding of the universe. It vows to push the limits of our knowledge about the universe, planets, and the origins of life itself, which started with high hopes transformed into a significant contention. The unexpected findings from James Webb have shocked the academic community. Will this disruption worsen? Or will new discoveries and debates in physics finally find resolution? But what does this actually mean? Have researchers actually solved the mysteries presented by James Webb's ongoing disclosures? Or are we being plated with insufficient explanations initially designed to provide clarity? The $11 billion project has instead plunged cosmology into turmoil. Every part of space-related inherent science is going through a seismic shift, equivalent to the worldview change from geocentrism to heliocentrism in the medieval times. We could need to admit that the foundations of modern physics are defective and that we may interpret the universe even a bit poorly. How did this happen? The modern astronomy, the study of the physical properties and relationships in the universe, is grounded in principles dating back to ancient explorers, the medieval times, and prominently Sir Isaac Newton, the ancient observations introducing the initial concepts of mechanics and elements with Newton later defining gravity, which is crucial for astronomy. These principles have underpinned our scientific perception of the universe, and we have extended Earth's legal and apparent quantities and forces to the universe, producing consistent results. However, when our visible universe expanded, these recognized amounts no longer describe what we saw. This situation arose with the conflicting results from various ways of measuring the age and expansion rate of the universe. Local measurements based on galactic objects conflicted with those of the early universe derived from the cosmic microwave background radiation, this mismatch known as the Hubble's tension, the Hubble constant indicating the universe's expansion rate, was called into question in the summer of 2022 when Webb discovered numerous ancient, highly evolved galaxies. These findings cast doubt on the universe's age. A universe ostensibly 138 billion years old cannot have advanced galaxies just 200 to 300 million years after the Big Bang. According to our physics, galaxies take billions of years to form. Webb's revelations, several galaxies existing before the Big Bang, challenged the traditional cosmology, which posits a 138 billion-year-old universe expanding from a single origin point. We are at a crossroads. Either we are incorrectly applying terrestrial physics to the entire universe, or we have only begun to uncover the true physics at play. The ancient scientist Hermes Trismegistus's adage, as above, so below, suggests that cosmic physics should mirror terrestrial physics. Perhaps we have overlooked forces and phenomena on Earth that are now evident in the cosmos. Webb's unprecedented capabilities are astounding. Its 18 hexagonal mirrors detect incredibly faint light signals, capturing light that has traversed existence for over 13 billion years. Revolutionary exposure techniques render these faint traces visible for the first time. Thanks to this new technology, we observed light from the most distant galaxies formed shortly after the Big Bang. In mid-2022, these galaxies, far from dim, appear fully developed and several billion years advanced. This aligns with a 135 to 136 billion-year-old universe. This paradox has led some scientists to deem these observations impossible or astonishing. However, Webb's data is unequivocal. Science must now confront the possibility that it has been on the wrong path for over a century, the approximate age of our current cosmological model. The reality Webb reveals is certain. Despite Webb's flawless execution, significant segments of our academic community struggle to reconcile with these new insights. Opposition from conservatives against departing from the Big Bang theory or the concept of evolution mirrors historical resistance to paradigm shifts. Just as it took centuries for the Church to accept heliocentrism despite overwhelming evidence, today's scientists face similar reluctance. Though modern researchers are no longer persecuted like Galileo, intellectual resistance and hostility toward groundbreaking discoveries persist. Imagine dedicating a lifetime to a theory only to have evidence challenge your beliefs. Such revelations would be difficult for anyone to accept. Thanks to Webb, a revolution has begun, causing both turmoil and heated debates. Yet we can hope that this crisis will bring us closer to the truth. However, we can rightfully hope that this crisis will bring us a little closer to reality. The unprecedented capabilities of Webb have indeed caused a sensation. Its 18 hexagonal mirrors detect incredibly faint light signals, capturing light that has traversed existence for over 13 billion years. Revolutionary exposure techniques render these faint traces visible for the first time. Thanks to this new technology, we observed light from the most distant galaxies formed shortly after the Big Bang. In mid-2022, these galaxies, far from dim, appear fully developed and several billion years advanced. This aligns with a 135 to 136 billion-year-old universe. This paradox has led some scientists to deem these observations impossible or astonishing. However, Webb's data is unequivocal. Science must now confront the possibility that it has been on the wrong path for over a century, the approximate age of our current cosmological model. The reality Webb reveals is certain.